The universe holds many secrets. One of the biggest is dark matter. It's a mysterious substance that doesn't interact with light. This makes it invisible to us, but don't let that fool you. Dark matter plays a huge role in the universe. It makes up about 27% of everything out there. Scientists are hard at work trying to understand this mysterious force. We know dark matter exists because of its gravity. It affects how stars move in galaxies. It also bends light, a phenomenon known as gravitational lensing. Without dark matter, galaxies wouldn't have formed the way they did. Scientists are using various methods to detect dark matter. These include looking for weakly interacting massive particles, or WIMPs, and axions. These particles are thought to be the building blocks of dark matter. Dark matter is a puzzle, but it's a puzzle scientists are determined to solve. Understanding dark matter is key to understanding the universe and how it came to be. The story of dark matter begins in 1933. Swiss astronomer Fritz Zwicky was studying the Coma cluster of galaxies. He noticed something odd. The galaxies were moving faster than they should have been based on their visible mass. Zwicky concluded that there must be some unseen matter holding the cluster together. He called it Dunkle Materie, German for dark matter. For decades, Zwicky's idea was met with skepticism. Then in the 1970s, astronomer Vera Rubin made a groundbreaking discovery. She was studying the rotation of spiral galaxies. Rubin found that stars on the outskirts of these galaxies were moving just as fast as stars closer to the center. This shouldn't have been the case if the only matter in the galaxies was the stuff we could see. Rubin's observations provided strong evidence for dark matter. These pioneering scientists paved the way for a new understanding of the cosmos. Their work revealed that what we see is just a tiny fraction of what's really out there. The evidence for dark matter goes beyond the movement of stars and galaxies. One compelling piece of evidence comes from gravitational lensing. This phenomenon occurs because massive objects, like clumps of dark matter, warp the fabric of space-time. This warping bends the path of light, much like a magnifying glass. By studying how light bends around distant galaxies and clusters, astronomers can map the distribution of dark matter. Another crucial piece of evidence comes from the cosmic microwave background, or CMB radiation. This faint afterglow of the Big Bang provides a snapshot of the early universe. The pattern of tiny temperature fluctuations in the CMB reveals the seeds of the large-scale structures we see today, like galaxies and galaxy clusters. These fluctuations tell us that dark matter must have been present in the early universe to provide the gravitational scaffolding for these structures to form. These lines of evidence, along with others, have convinced most astronomers that dark matter is real. It's a fundamental component of the universe, even though we still don't know what it's made of. Dark matter is unlike anything we've ever encountered. It doesn't interact with light, making it invisible to our telescopes. It doesn't seem to interact with ordinary matter very much, if at all. This makes it extremely difficult to detect directly. Scientists have proposed various theories about what dark matter could be. One leading candidate is weakly interacting massive particles, or WIMPs. These hypothetical particles would interact with ordinary matter only through the weak force, which governs radioactive decay and gravity. Another possibility is axions, hypothetical particles that were originally proposed to solve a problem in particle physics. Despite decades of research, dark matter continues to evade detection. However, scientists are developing new and more sensitive experiments to try to unlock its secrets. The search for dark matter is a journey into the unknown, one that could revolutionize our understanding of the universe and the fundamental laws of physics.